first problem, I have one that is open at both ends. And the question is, what are the first three harmonics in a 2.45 meter long pipe that is open at both ends? And we are to assume that the speed of sound is 345 meters per second. So for this problem, we have our givens, which are L equals 2.45 meters and V equals 345 meters per second. What we are looking for is the three harmonics. So we're going to use the equation f of n equals the number times the velocity over 2 length, and then n would equal 1, 2, 3. And now we're going to sub in our givens into our equation. So we have 1, since we're looking for the first harmonic, times the velocity, 345 over, multiply this by 2, so 2 times the length, which is 2.45. If we do that on our calculator, we get that this equals 70.4 hertz. Then, to find the next two harmonics, we are to multiply this by 2 for the second and 3 for the third. And multiplying 70.4 times 2, you get that the second one is 140.8, and the third harmonic is 211 hertz. And this is, what are the first three harmonics in a 3.01 meter long pipe that is closed at both ends? And we are to assume that the speed of sound is 345 meters per second. For the pipe that is closed at one end, we're going to do our givens. L is 3.01 meters, and V equals 345 meters per second. Next, our equation, which is the number times V over 4L instead of 2. Next, all we have to do is substitute. So we have 1 for the first harmonic times the velocity, which is 345, over 4 times 3.01, which is the length. Once we do that, we get 114.62. And then to just find the next possible, the third and fifth, we multiply, or the second and third, we multiply to find the second by 5, or by 3, to find the third by 5. And those answers would be the second is 343.85, because that's multiplied by 3. And the third would be 573.1. And that's how to find the three harmonics on a closed end.